I am R. Krishnaveni. I am working as an assistant professor in ECE department, KIT Kalinger Karunanidhi Institute of Technology, Coimbatore. My topic is pulse modulation. In this topic, I am going to discuss about the different types of pulse modulation and pulse code modulation block diagram. First, we see the introduction. Nowadays, modern communication systems, many signals are in digital. So we can able to convert the analog signals into digital signals. So why we are going for this conversion? For reduce the distortion and improvement of the signal to noise ratio. Data transmission, digital transmission or digital communications is the physical transfer of data, digit bit stream or digitized analog signal over a point to point or one to one or point to multi-point communication channel. In pulse modulation, there are different types: PAM, PWM, PPM, PCM, and DM. Pulse amplitude modulation, pulse width modulation, pulse position modulation, pulse code modulation, delta modulation. Other than this, other types are ADM, adaptive delta modulation, DPCM, differential PCM. So normally the communication channel may be wired or wireless. Example, wired optical fibers, wireless channels, computer buses or wired channels. Mainly main types of modulators are continuous wave modulation and pulse modulation. In continuous wave modulation, depending upon on the parameter of the waveform, there are amplitude modulation, frequency modulation and phase modulation. Combining frequency and phase modulation, it is called the angle modulation. In continuous wave modulation, our input carrier signal and modulating signal both are analog in nature. In pulse modulation, our input is analog signal and carrier signal is sampling pulses. So there are two types in analog modulation: analog pulse modulation and digital pulse modulation. There are two types of pulse modulation. In analog pulse modulation, PAM, PWM, PPM. This analog pulse modulation, other than we have the digital modulation, that is PCM, delta modulation. So analog pulse modulation, these are the different types. So in analog pulse modulation, amplitude of the carrier signal is varied according to the modulating signal. We get the pulse amplitude modulation as shown in the figure. First one, PAM signal, second one, PWM signal. Carrier width is varied according to the input modulating signal. Third one, PPM signal. Position of the pulse is varied according to the input signals. These are the representation of analog pulse modulation. Digital pulse modulation. So types are pulse code modulation, delta modulation. Output of the pulse code modulation is digital in nature. This is zeros and ones. So output of the pulse code modulation is discrete values, zeros and ones. Now we are going to see about the pulse code modulation, PCM. It is one of the digital modulation technique. So here we are using the A to D conversion principle. It consists of sampling, quantizing and encoding. So normally why we are going for the sampling? Sampling is the process for converting the continuous analog signal into discrete signal. So we measure the samples at the equal interval of time. This is called discrete in nature. Quantization. So sampled values are quantized using quantizer. It is called round off to the nearest value. Example, your input is 2.7 means it is rounded to the 3 volt. So we rounded to the 3 volt, we get the quantization error 3 minus 2.7.3. It is called the quantization error or quantization noise. Encoding means converts the quantized signal into digital form. It is the PCM transmitter, sampler, quantizer, coding. Sampling is done by the PAM, pulse amplitude modulation. So input of the PAM, it is the continuous in nature and continuous in time. So output of this PAM is continuous value discrete time. Output of the quantizer is discrete value discrete time. Output of the coder encoder is digital encoded value. A, B, C are the three pulses. Value of these pulses are 3.8, 1.2, 5.7. These are quantized using quantizer. You get the round off value. Encoder encodes the quantized value. We get the binary digits as shown in the table. So PCA transmitter consists of three main parts: sampler, quantizer, encoder. Output of the PCM is digitized pulses, zeros and ones. These digitized pulses are transmitted to the receiver through the communication channel. During the transmission through the communication channel, noises or distortion will be added. So see this figure, first one transmitter pulse, zeros and ones. So noise is affected, we get the received pulses as shown in the figure. We cannot get the original transmitted pulses. These are the effect of transmission noise on encoded pulses. This is the main PCM system. Input of the sampler is analog signal, output is samples. So this sample signal is applied to the quantizer, you get the rounded value. It is applied to the encoder, we get the binary digit as shown in this figure. So again these binary digits are applied to the receiver and then applied to the decoder and holding circuit and low pass filter, we get the original analog signal as shown in the figure. This is the main PCM block diagram. In PCM transmitter, we do the analog to digital conversion. In PCM receiver, we do the digital to analog conversion. So regenerative repeaters are used for removing the noises and distortions and interferences. So the regenerative repeaters are located equal distance at the transmission medium for avoiding the distortion and noise and improve the signal to noise ratio. This is the regenerative repeater circuit diagram. So it consists of the three parts: equalizer, timing circuits, decision making circuit. Distorted signal is applied to the regenerative repeater equalizer. Output of the decision making device is the regenerated PCM signal without any noise. So the output of the PCM signal is 0, either 1. There is no intermediate values. This is the PCM output, 1s and 0s are shown in the figure. So this reconstruction filters are used to get the quantized PAM signal. It is applied to the low pass filter, we get the original analog signal. Normally quantization noise is del squared by 2. Signal to noise ratio of PCM is 1.8 plus 6n decibel. Normally n is the number of bits in the PCM. Fs is the sampling rate. So normally bit rate is defined as NB into Fs. There are two types of the noises in the PCM systems. First one is transmission noise. Second one is quantization noise. What is transmission noise? It is introduced anywhere between transmitter output and the receiver input. Quantization noise. It is introduced in the transmitter and it is carried out along the receiver output. Thank you to all.